Okay, so this is a quadratic application, typical application problem using the quadratic formula. We've got the equation h equal negative 1/2 g t squared plus v naught t plus h naught. Okay, so this formula is used in general. Robert stands on top of the bleachers and throws a ball. Okay, so we got this guy, Robert. And he's standing on the top of the bleachers, whatever. These are silly little bleachers here. Okay, and so Robert hurls this ball, okay, from the top of the bleachers out onto the field. So maybe we've got our field out here. Okay, whatever. Now, when he throws the ball, he throws it upward at a velocity of 60 feet per second, and the ball is 50 feet above the ground at the moment he releases it. Okay? So, when does the ball come and hit the ground? Okay, so when will the ball hit the ground? Now, anytime we're working a word problem, the first thing I want you to do is I want you to go through and circle all the numbers you're given. Okay? This is going to help you out with any word problem. Doesn't matter what class it is. 60 feet per second. Okay? Now, what does this have to deal with? All right, vertical velocity. Okay, where do we see velocity? So this is how fast the ball is thrown whenever it leaves his hand. This is 60 feet per second. So my V naught here, what do we know? So we know that V naught is 60 feet per second. Okay? All right, what else do we know? Well, let's look through more numbers. Here's another number. The ball's 50 feet above the ground. Okay, so when I draw my picture, this is helping me with my we know. I'm 50 feet above the ground where the ball is let go. Okay, so my initial height, my starting height, h naught, this is 50 feet. Okay, and what else do I know? Well, my units here are in feet and feet per second. So I know that I'm going to be assuming that my gravitational pull is 32 feet per second squared. Okay, this is an assumption. If it was in meters per second, then I would say 9.8 meters per second squared. But since we're dealing with feet and seconds, we know to use 32. So let's plug into our equation. So the height, h, how high the ball is at a given time, is equal to negative 1/2, and then g is 32 for this problem since we're dealing with feet and seconds. And then time squared, that's what we're looking for. What we know, what we want. That's how we can always break down any word problem. What do I want? I want to find the time at which the ball hit the ground. Find the time when the ball hits the ground. What's the height of the ball when it hits the ground? The height is equal to 0. Okay, so plus V naught, which is 60 t, plus 50. So I replace h with 0. I want to know when it's 0. So 0 equals negative 16 t squared plus 60t plus 50. Using the quadratic formula, okay, I can take a 2 out of all these. Make it a little bit easier. So 0 is negative 8t squared plus 30t plus 25. So I can use the quadratic formula, or I can graph this thing. So when I graph this, quadratic formula is going to produce 15 plus or minus 5 square root 17 over 8. So when I type that in a calculator, t is going to be roughly negative 0.7, or t is going to be roughly 4.45. If you're wondering how I got these decimal numbers, there's a video on how to use the quadratic formula. You can go watch that one. And if you graphed it, it might look, maybe something like this. Okay? So the ball is leaving his hand here, and it's coming down, and it hits the ground right here. Okay? So what does this represent? This tells me that the ball lands 4.45 seconds after leaving Robert's hand. Okay? All right.